Hello, CP Algebra 2A, and welcome to the 1.3 Solving Linear Equation Notes. Again, this should be rather refreshing, and hopefully you remember how to solve linear equations. So go ahead and get your pencil, get some spare paper. Be sure to answer the essential question, how do you solve linear equations? Of course, at the end of our notes here, and calculators will also be of assistance. Okay, now solving linear equation is all about maintaining balance. Okay, as you know, I've studied yoga over the summer, and a lot of the poses in yoga require balance. Okay, whatever you do to one side, you must do to the other. So whatever operation on one side, operation on one side of the equal sign, you have to do the same operation on the other side. Same operation. Balance. A lot of times you could think the little scales sometimes. They're often a balance like this, old school balance, okay? You need to keep balance. Whatever you do to one side, you do to the other, okay? So, solve an equation with a variable on one side, level 1. Easy peasy stuff. Well, 4/5 x plus 8. Wow, hitting you guys with a fraction already, but don't let them scare you, okay? Don't let fractions scare you. Don't be afraid of fractions. Okay? Easiest way to deal with fractions is multiply by the denominator. Multiply by the common denominator. By a common denominator. And for our case, our common denominator, we'll say, is 5. That's the only denominator we see. It will get a little trickier if you have more than one. But for us, if you just multiply everything by 5, so 4/5 times, Gotcha there. 4/5 x plus 8 equals 20. Again, we're going to multiply each side by 5 because that was our common denominator. Now, what's going to happen? First, you need to distribute the 5. Okay? 5 times 4/5. If you do that in your calculator, a fancy thing happens. And the reason we choose 5 is, really, they just kind of knock each other out. So you're left with just a 4 and x. Now 5 times 8, hopefully you can recall that to be 40. And 5 times 20 is 100. Fraction is gone. This should look relatively gentle now, I guess. Okay, we're going to subtract 40 from each side. Whatever you do to one side, you have to do to the other. We get 60 equals 4x. And we're going to divide each side by 4. 60 divided by 4, x equals 15. Now, what I recommend you do in the future is you do the Dvorsky double check. And what that means is you just take your x equals 15. You did all that hard work, substitute it back on in for x. Remember, when we substitute, you want to use parentheses. And when you do that, 4/5 x plus 8 equals 20, you should get 20 back out. So the Dvorsky double check your answers. You guys put a lot of hard work into them, So you might as well go back and double check. You don't want to do all that work just to lose points and find out you made a silly mistake. Okay, now solving equations, notice we subtracted first. Okay, first we distributed, then we subtracted. Solving equations is about going the opposite direction of PEMDAS, okay? You're kind of working backwards. LP1 or L1 practice, I'll leave that up for you. That is a -3/5 x. I will let you guys know the solution here in a second. I think so, at least. At the end, I'll give you the solution. But L1 practice, that's for you to try, okay? So I'll let you know that at the end. But let's move along here to level 2. Solve an equation with variables on both sides. So we're just stepping it up a little bit. Level 2. Alright, it's not bad. You just want to get one variable on one side. Okay? It doesn't matter which one you choose. It doesn't matter which side. So long as you do the math correctly. Now, what I like to do, though, is try to keep variable terms, positive. Okay, so notice here, 7p and 9p. They're on different sides of our equal sign. Okay, so we want to get them to one side. Well, if I subtract 9p, 7 minus 9 is going to give me -2p. Okay, if I subtract 7p, then I'm left with a +2. I didn't do anything with the constant terms. And 13. It will not throw off your answer if you do choose to subtract the 9. It just makes it a little bit easier for us. So, I took care of my like terms. P is just on one side. We're going to add the 5 over. Boom, 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 boom. 18 equals 2p. Divide by 2. Divide by 2. 9 equals p. Kind of looks funky there. 9. And that's a p. Okay? So, get variables on one side. Doesn't matter which side. Try to keep the terms positive. Okay? Again, we'll leave that one up to you. Level 3. Solve an equation using the distributive property. Now we're starting to shake and bake. Well, we already did a little bit of the distributive property in level 1. And just be careful. Distribute everything. Don't under distribute. What do I mean by that? A lot of times students will say, oh, we got to distribute to 3 to the 5x. So we'll get 15x. And what they'll do is they'll just write 8 minus 8. Well, you have to distribute to everything. The -8 one's in the party. So minus 3 times 8 is 24. Okay, don't forget to distribute to everything in parentheses. Now here's the little difference here. Let's use a different color. -2 times -x. Take it slow. That gives us +2x. Well, what happened to the negative, Mr. D? Well, notice we have a negative times a negative. Okay, so it becomes a +2x. Also, -2 times +7. Here we have a -2 times +7, 14. -14. -12 is not part of this group. Okay, he's not part of this crew. He's doing something else. So we don't need to distribute to it. You just write down the negative 12x. Now, we got lots of variables here. We have this x, we have this x, we have this x. So let's just kind of make them a little nicer. So we have 2x minus 12x. That's negative 10x minus 14. All I did was combine these x's. 15x minus 24. Now we have variables on both sides, so this is like a level 2. Okay. So let's make, well, we want this to be positive, so add our 10x. We get 25x minus 24. And if you are comfortable going a little faster and saying, well, I'm going to add my 24 over in the previous step, that's fine, but I mean, it's not taking you too long to do this anyway. So just take your time, because that's where a lot of little mistakes occur. Negative 14 plus 24 here. Just be careful with the negatives again. It's nothing too crazy, but negative 14 plus 24, that'll give us 10. 25x. And the other thing is students get so afraid of fractions again. Don't be scared. Do not be afraid. Don't be afraid. It's just a fraction. Just a fraction. Okay? Now, that will reduce. 10 and 25 each have a factor of 5. And if you substitute in your calculator, you'll get x equals, let's see, divide everything by 5, 2/5. Again, I recommend the Dvorsky double check. Substitute it back in to here and here in the very original. Okay? So, distributing and keeping variables on both sides. Again, there's another one for you. I'll get to the answer later. If you have extra time, I'll be walking through those. But again, I want these to kind of be quicker, and many of you have probably done these in the past, so I know you have, in fact. Now, application problems. So we do need to focus on these because applications are really where the math is, okay? It's fine that you can do the concept stuff, but we just get so afraid of application problems. But these are where it's just, this is where math is used, okay? Applications. Rebecca makes a base pay of $30, okay? Each shift she as a waitress, okay? So every shift she's guaranteed $30. Okay? Helps to write things down. Every time, every shift, she gets $30. Walks in the door, she's like, hey, I'm here, give me my $30. She also makes an additional 15% off of the customer's bills. So, depending on the customer's bills, which they can change, right? Maybe there's a lot of customers that day and it's a high number. Maybe there's not too many and it's a low number. That means it's a variable. So customer bills will say that those are B, so a variable. And again, it can change. And she makes 15% of the bills. Now, 15%. When you need to write percentages as decimals, because that's what we'll need to do, is you move the decimal point 2 spots, or you divide by 100. So she makes 0.15 of each bill. Okay, $30 when she gets in the door, 15% of each bill. All right, she has been working hard and really wants a pair of new shoes. Let's draw some new shoes, perhaps. Really wants this pair of new sneakers here. New, maybe they're Nike, or no, I'm an Adidas fan. Okay, new shoes. She really wants them here. We got they have the shocks and everything. All right, let's put some color in there. Bam, bam, bam. All right, so she really wants a pair of new shoes. Now we need two shoes here. This one's just kind of off to the side, and it's like the front or the top. Okay, anyway, pair of new shoes, shoelaces. Okay, she really wants them, so they cost $105. Shoes are expensive anymore. I don't know why, but they're ridiculous. Okay, she's going to the store after work and hopes to make enough money during this single shift, so she just wants to make money during this one shift to buy the shoes. She wonders, how much am I going to have to sell to get them? So we're going to let X be the cost of food bills. I jumped ahead and said it was B. We'll let B be the cost of food bills. Okay, since we already did that. Write a verbal model representing Rebecca's base pay. Verbal model. Okay. Again, we kind of did this. She makes every shift. She gets $30 plus 15% of the customer's bills. And we know that that makes her, not cost, but that is her pay for the day. Okay? That's her pay. Here's your verbal model. All right? Equals P equals pay. As long as you have this, that's fine. If you have these in opposite directions, that's fine as well. 0.15x plus 30 equals P. Okay, that's our, what property is that? Well, they're commuting each side. That's our commutative property. Don't be forgetting those. Okay, and that is what she can use to determine how much money she has. So, at the end of her shift, Rebecca sold a total of $625 in the food bills, along with the shoes. Does she'd like to get a magic purse? Does she have enough money? Did we finish up this one here? Make sure we answer the questions. She goes into work here. Okay, so for this one here, we want to know, does she make enough money to actually get these shoes? Here's the verbal model, and now we'll just solve it. So 30 plus 0.15x. We want to know how much to get her 105. All right, well, solving, we're just going to subtract 30. Okay, 105 minus our 30 gives us 75. Equals 0.15x. Now, dividing by decimals. You can just type that right into your calculator. Divided by 0.15. 0.15. Again, use parentheses. Highly recommend the use of parentheses. Okay, and what you should get out is she needs to sell $500 worth of food bills. Okay, so $500 is what she knows she needs to make. However, she can do that. All right. Now, that's the basics of the word problems, okay? Now, these ones here, they're going to make you think a little bit more. Oh, no, Mr. Dvorsky. Okay, so try this one. At the end of her shift, she sold a total of 625. Along with the shoes, if she has enough money, she'd love to get a matching purse. Okay, so does she have enough money? All right. So if you're feeling the challenge, if you have some extra time, go back through, work on B, work on L3, L2, L1, but make sure that at least you solve or you answer the essential question, okay? In a moment here, I am going to go through L1P, L2P, and the others, but you are free for right now, and that's all, okay? So if you want some extra practice, follow along with these here. Otherwise, come to class tomorrow ready to go. You're going to be solving L1P and such anyway, but this is for you overachievers. So, thanks. If you're still with me, we will wrap through these real quick, okay? L1P, first thing we're going to look at is subtracting 1, opposite order of operations. You get 3. Boom. Negative 3/5 x. This is a little different way. I know first over here that we multiplied by 5. Well, if you do either one first, it's really okay. So here I subtracted first. Now, again, we're going to multiply by the 5 to wipe it out. Boom, boom, boom. Boom, boom, boom. Negative 3 equals 3 times 5 is 15. Divide by negative 3, and x equals negative 5. Okay, be careful. We divide by a negative. This is a positive divided by a negative, so you get a negative. Now again, I'm going to check this because it has a fraction, which is scary. Not really. And just to be sure. Negative 3/5 times negative 5. That will give me positive 3. Plus 1 equals 4. And 4 equals 4. We're good to go. Okay, so x equals 5. This here, again, is just the Dvorsky double check. Okay, lesson or level 2. Variables on both sides. Uh-oh, what's going to happen here? We're going to add over our 2x, giving us 4x, minus 7 equals 9. Add 7. Bada bing, bada boom. 9 and 7 is 16. Divide by 4. And 4 equals x. That one was pretty easy, so let's go ahead and double check, of course. Now be careful, make sure you substitute it into both spots. Negative 2 times 4 is negative 8, plus 9 equals 8 minus 7. Negative 8 plus 9 is 1. 8 minus 7 is 1. We are happy it works out. So 4 equals x. Level 3. We're going to distribute that bad boy, or girl. Negative 4 times 2x, negative 8x, minus 20, negative 2x, minus 18, minus 4x. We're going to combine our like terms. Let's see. So, any recommendations? Let's add 8x to keep it positive. Now, don't forget the negative. Okay, bring the whole thing down. It's negative 20. Add 18. Negative 2 equals 2x. Divide by 2, divide by 2. And x equals negative 1. Again, negative divided by a positive is negative. Okay? Dvorsky double checking this one. Since you're here for the time anyway. Negative 4 times 2 times negative 1 plus 5. We'll kind of do them separate here. Negative 4, this is order of operations. So 2 times negative 1, that's negative 2 plus 5. Negative 2 plus 5, that's positive 3. Times negative 4, that means negative 12's on the left. And for this one here, so this is the left-hand side. 2 times negative 1. It's minus a negative. Minus 9. Minus 4 times negative 1. It's positive 1. Minus 9 is negative 8. Times 2. Plus 4. 16 plus 4. I mixed up a negative here, didn't I? I believe so. Equals 20. Minus 9. That would be a negative. Very good. See, this is why you take your time. Okay? I tried being a champ, but negative 1 minus 9 is negative 8. I actually saw it there, but I did not write very neatly, meaning this is negative 16 plus 4, giving me the negative 12. So negative 12 on the left equals negative 12 on the right, and x equals negative 1. Okay? Rebecca and her shoes. End of her shift. Rebecca sold a total of 625. So X or B equals 625. Along with the shoes, does she have enough to get a matching purse? So, oh my, what happened here? I'm sorry. Okay, along with the shoes. So, let's see, shoes plus purse equals 105 plus 75. 105 plus 75 is 180. Okay, well, 30. That's how much she makes just from walking in that day. Plus 0.15 times what she made off of the bills. We want to know, is it enough for 180? Okay, so 15 times 625, 15%. Yes, I'm going to get my calculator out. 0.15 times 625, 93.75 plus 30, and I can already tell, Rebecca, you do not have enough for both the shoes and the purse. She did not sell enough for both. Okay, but just use your mind a little bit. Take your time. Don't let word problems scare you. We are going to be emphasizing them more throughout class. So Thanks if you watched those. Again, that brought us up to the 30-minute mark, so pretty good there. Bring any questions tomorrow, and have a good day.